In looking at this exponent rule, we can see that the bases are the same, and we are going to be adding the exponents. So anytime that we are multiplying like bases, what we do with the exponents is we add them. So for instance, right here, this is my general rule. If I have a to the b times a to the c, that's going to give me a to the b plus c. And we would add these numbers together. So for example, if you take a look at number 1, see how it says y to the 7 times y to the 5th? Those y's are the same, so what we're going to do in order to get our answer is add 7 plus 5. So this would give me y to the 12th, because 7 plus 5 is 12. If we look at number 2, now we have 3 of them that we are going to be adding, because we have n to the 4th times n to the 3rd times n to the 2nd. So we would end up adding the 4 plus the 3 plus the 2, since they're all n's. And if we do that, we would end up getting n to the 9th. Now, if we take a look at number 3, I want you to put a star next to it. A lot of times, this is the kinds of problems that students tend to get incorrect. And the reason why students get this one incorrect is because if you look at the base, see how the base here is a 2? A lot of times, students will not leave the 2 as a 2. But you need to leave the base the same. Take a look at number 1 and number 2 again. See how my base on number 1 was y, and we left it a y? See how the base on number 2 was an n, and we left it an n? That means right here, because we have a base of 2, we need to leave that base as a 2. And all we're doing is adding the exponents. So we would add the 3 and the 4 to give me 2 to the 7th. 2 to the 7th. Now number 4, we're going to start mixing up different bases. And you have to be very careful with this. You need to identify the base that goes with the other base in order to add them together. So that means that right here, we would be combining the t's together, and then we would be combining the c's together. So let's look at the t's first. The t's have exponents of 13 and of 18. So we are going to add those together. So my base of t will stay my base of t, but then I would add that 13 plus that 18 to give me that exponent of 31. If I add my c's now, my c has an exponent of 15 and an exponent of negative 3. Well, if I add together my 15 and my negative 3, I would get an exponent of 12. So my answer here would be t to the 31, c to the 12th. I can't go any further because t and c are not the same base. So we would leave it just like this. Now let's take a look at number 5. It's again getting a little bit more complicated here. We see that we have bases of c, a, and t. But if we look way out in front here, we have coefficients to each one. We have a 3 and we have a 5. Well, those are not bases. Those are not bases. Those are just coefficients. So we do exactly like what we normally do with coefficients when they're multiplied together. We would multiply them here as well. So 3 and 5 would give me a new coefficient of 15. Now we can look at each one of the bases. So I have a base of c, and I would add them together. So I would have 3 and negative 1, so I would have a c squared here, because 3 and negative 1 is 2. Now I look at my a. My a is right here, my a is right here. Well, if we look at that first a, even though I don't see it, there is an implied exponent of 1 right there. So this a is actually going to have an exponent of 11 because 1 and 10 is 11. And then if we go ahead and take a look at that t, I have a 16 and a 5. So that t exponent is going to be of a 21. It's going to be of a 21. We're going to do 2 more together, and then I'm going to have you guys try the next 4 on your own. So if we take a look at number 6, again, number 6 has coefficients. It has this negative 6 and this 4. We deal with coefficients just like how we dealt with them before. We would multiply them. Well, negative 6 and 4 is going to be a negative 24. And I'm going to write underneath this just because I'm not going to have enough room on that little line right there. If I look at my base of D, it has a negative 2 and a 12. So that D is now going to have a new exponent of 10, because negative 2 and 12 is negative 10. Then I have my O. My O has a 5 and a 7. So my O is going to have a new exponent of 12. And then I look at the G. This one has a 6. Ooh, but if I look at this one, it doesn't have one, but it does have an implied 1. Even though I don't see it, it is right there. So this is going to have an exponent of 7. And that's as far as I can go on that one. Now if I look at number 7 looks complicated, but it's actually the same exact thing as 5 and 6. There are just 3 things that we have to deal with. So the coefficients for number 7 are negative 7, 3, and 3. So if I multiply negative 7 times 3 times 3, I would get a negative 63. Now let's look at our base of W. W I see is here. W is here, W is here. But even though I don't see it, on the first one and on the last one, it has exponents of 1. So I have a 1, a 13, and a 1. So that would give me W to the 15th. Now I would take a look at the C. This C has a 3, this has an 8, and this has a negative 3. So if I combine the 3, the 8, and the negative 3, I would get a C to the 8th. If I look at the T, I have a T here and a T here. And even though I don't see it, both of them have an exponent of 1. So 1 and 1 would give me T squared. And then the very last one that I have here is this lonesome V. He has nobody else to combine with, so he just kind of goes at the end. So I want you to go ahead and try 8, 9, 10, and 11 and ask me to double check you.